Hi, we are still in Module 2, Electricity Spot Markets, and now reaching the third block, from prices to settlement. What is the settlement process? Remember that so far we've defined the auction mechanism to match supply and demand. We've written this problem as an optimization problem, and out of this optimization problem as outcomes we got energy schedules for the supply and demand side and a price, a market clearing price or system price that came out of this matching of supply and demand. Now comes the settlement process. Using everyday terms, who should pay what? Who should get paid and what amounts? Already now, we should think of the fact that obviously it's those who are not scheduled through the market clearing, so suppliers that will not sell anything or consumers who will not end up consuming anything, they should not pay anything or receive any amount of money. But in general, what do you think should be the rules of settlement? Who should get paid and what? Who should pay and what? In electricity markets, there are two main approaches to settlement. They rely on the one hand on pay-as-bid pricing and on the other hand on uniform pricing. We will describe these two approaches in the following slides. But first of all, we're going to use the same example auction setup already from the previous block and the previous block so as to exemplify and illustrate what's happening with these various approaches to settlement. On the supply side, you recognize the various companies that we met before, Rogue Trading, We Trust in Wind, etc., with their various supply offers in terms of a quantity and a price. This is the price they are ready to get paid for to supply energy through the market. On the demand side, similarly, we recognize the companies that we've met before with their various consumption offers in terms of an amount and a price. This price is the price they were ready to pay per unit of energy they could consume through the market. The schedule now we got out of our market clearing. Remember that the first 8 supply offers were accepted, with the last one from G8 partially scheduled, so not the full amount that was originally offered is scheduled. And for the last suppliers, the amount is 0. That means they are not going to supply energy through the market. On the demand side, D1 through D9 were fully accepted. So that means they can consume the amount of energy they originally offered to consume through the market. And D10 to D12 are scheduled to 0. That means they are not going to consume any amount of energy through the market. Remember also the system price, which is of 37.5 euros per megawatt hour and which correspond to the price offer of G8. Now that we have set the scene, let's look at the first approach, settlement with pay-as-bid pricing. So how does that work? Pay-as-bid pricing relies on the basic idea that if you offered a certain price to supply, then this is the price you're going to receive for what you supply through the market. Similarly, on the consumption side, if this was the price you were ready to pay for each and every unit of energy to consume, this is the price you're going to end up paying. So mathematically, on the consumption side, the revenues, which are going to be negative since these agents are paying, are the result of a multiplication of the price they originally offered times the amounts that they end up consuming. As I said before, this revenue is negative since it's actually a payment on the consumption side. On the supply side, the revenue of those generating, of those supplying energy through the market is going to be the result of a multiplication between the price that was originally offered by this agent J here times the quantity that is eventually scheduled through the market clearing here. The revenue, again, is positive since it is actually receiving money as a supplier of energy in the market. As an example, based on our market clearing, which we described before, D1, which is the first block of electric energy consumption being accepted, the first offer, it's going to pay 250, that's the amount of megawatt hours of the offer, times 200 euro per megawatt hour. This was the price that was offered by D1. This ends up to an amount of 50,000 euro, a negative amount since it's a payment. Sorry. D2 then is paying 300, that's the amount of energy that was offered to consume in the first place, times 110 euro per megawatt hour. Since that's the price, D2 was ready to pay for this energy to be consumed. And this yields 33,000 euros. And so on until D9, which pays 30 for the amount, times 38 for the price that it was ready to pay, which yields 1,140 euro. On the supply side, so for positive revenues, for those who receive money from the market, G1 receives 120 for the quantity that was offered in the market, times 0 euro per megawatt hour, since this was the original offer. So that means that the actual revenue of G1 is 0. It doesn't get anything out of the market. Then for G2, there is another quantity. This was 50 megawatt hours, but the price was the same, 0 euro per megawatt hour. So that means that the second supply offered in the market also translates to a revenue of 0. If we continue for all the other scheduled offers, G8 received 55, that's the amount of energy eventually scheduled, times 37.5, which was the price that was originally offered for G8, and which amounts to 2,062.5 euro. Do you foresee the potential consequences of pay-as-bid pricing in terms of feed cost recovery for energy producers and strategic behavior of market participants? First of all, when it comes to fixed cost recovery, you can imagine that this G1 and G2 receiving 0 from the market, they are not going to recover much of their fixed cost. For agents in general, if they enter the market declaring their marginal cost for producing energy, this marginal cost is only there to cover the variable cost for producing energy. Those fixed costs relate to investment, installation, etc. They cannot be recovered just by being paid for the variable cost part. So that means that in general this will incentivize the supply side agent to push up their price so that they recover their variable cost part and also the fixed cost part for the operation of their supply unit, their energy supply units. In terms of strategic behavior, you can see that since you're going to be paid the price that you originally offered, on the supply side, you want to push this price up. And on the consumption side, since you're going to have to pay the price you originally offered, you have an incentive to push down the price for your offer. But what is the condition for you to be scheduled and to eventually pay this price? You need, on the consumption side, that your price offer is higher than the equilibrium price, and on the supply side, your price has to be lower than the eventual market clearing price. So there can be a kind of game on the consumption side and supply side. You would like to predict what's going to be this equilibrium price, the market clearing price, and then on the consumption side you want to be just above it, and on the supply side you want to be just below it, so as to maximize your potential revenue or minimize your potential payment. Let's move on to settlement with uniform pricing. How does that work? We rely on a similar idea on the supply and consumption side. We're going to need a price times a quantity for payment and for revenue. But here, we're going to use as a price directly the market clearing price. This is why it's called uniform pricing, because everybody is dealt with the same price. So on the consumption side, your payment is going to be the market clearing price times the quantity scheduled for consumption. Again, it is negative since being a payment. On the supply side, your revenue is going to be the market clearing price times the energy amount being scheduled. It's positive since really being a revenue here. Let's look again at our example and compare with the previous situation. In that case, for the first consumption offer D1, D1 is going to pay 250 for the quantity schedule times 37.5, which is the market clearing price. The eventual cost is 9,375 euros. Already, if you compare with the previous situation, here it was 50,000 euros because the price offer was very high. Here, the payment is only going to be 9,375 euros since the price to pay per unit of energy is quite much lower. D2 will have to pay 300 times 37.5, which is 11,250. Again, it's quite lower than the 33,000 that D2 would have to pay in a pay-a-bid pricing system. Eventually, as we go to D9, the total payment is 1,125, and here it's quite close to the payment in the pay-as-bid system, since the actual price offer for D9 is very close to the market clearing price that we got out of our market clearing. On the supply side, now G1 receives 120 for the amount being scheduled times 37.5, which yields 4,500 euro as a revenue. Compared to 0 in the pay-as-bid system, you can imagine that it's a plus for G1. Similarly for G2, 50 for the quantity times 37.5, this gives 1,875 euros, which is also higher than the 0 euro that was received in the pay-as-bid pricing case. For G8, the situation is the same since G8 was setting the price in the market. So being dealt with pay-as-bid system, receiving 37.5 per unit, or under uniform pricing, receiving 37.5 per unit, we end up with the same revenue. Does that look like a better system? Some argue that uniform pricing has some benefits, but some actually prefer pay-as-bid settlement in electricity market. In principle, the argument for preferring uniform pricing is that it's expected to attenuate some of the potential negative consequences which I discussed earlier for pay-as-bid pricing. Let's now discuss more generally what are the properties that are induced by these two settlement approaches. First of all, day-ahead market with the two settlement approaches guarantee what we call individual rationality. This is since, in both cases, the consumers will pay at most what they were ready to pay, and producers will receive at least what they wanted to be paid for, which you can write mathematically this way. So the revenue or the payment eventually for the consumer is going to be at maximum the payment that he was ready to make, and on the supply side, the revenue obtained is at least the revenue that the supplier wanted to get if scheduled. All right? So eventually here individual rationality means that no one entering the market is not doing on his free will. That means that they want to enter the market because they know that they're going to receive money out of their participation. They're not going to lose money. Second, day-ahead markets with the two settlement approach, they guarantee revenue adequacy. So that means that overall, if you look at all the agents on the supply side and on the demand side, the sum of the revenues is greater or equal to the sum of payments. So there's not money lost through this market clearing, money that we would have to make come, for instance, from subsidies or some other type of regulation. Here, by clearing the market, we are sure that there's going to be revenues that are greater or equal to the sum of payment. There's no money lost on the way. Finally, One of the two settlement approaches is yielding budget balance, which is the correspondence, the strict correspondence between the sum of the revenues and the sum of payments. So if you rethink this inequality, actually we have, in the case of uniform pricing, a strict equality, while in the case of pay-as-bids, we only know we have this inequality, but we don't know if we can get the equality. Thank you for listening. Now I would like to invite you to use the self-assessment quiz to check your understanding.